Well, good afternoon, Cohort B. I would just like to say that I hope you enjoyed your evening together with your eyelash mites. Just remember next time you go to bed that yeah, eyelash mites. You're never really alone, are you? Right? So just keep that in mind. Something to think about. All right. Hey, listen. We have exactly 2 lessons left. There was one here today, and there's the other one you're going to be in class for tomorrow. Then that's it. We're done, and we're just going to get ready for your test on Thursday next week. Okay, so a week from today, we'll have our RST. You get your cheat sheet ready. Okay, and yeah, and then we'll have a little test. It'll take maybe about an hour and a half to do it, but it'll cover all the units. So yeah, I'll give you back your electricity test tomorrow. We'll go from there. All right, so let's do this. I wanted to, because we live in Canada, I thought we'd do a little survey of the major Canadian biomes. A biome is a large area with a characteristic climate. I don't expect you to memorize any of this or anything like that. I just thought it would be interesting. Okay. If you look at where Ottawa is on this map, we are down there where the arrow is at the bottom of the screen approximately. So you can see Lake Ontario there where the arrow passes through that. Here, I might as well mark it for you on the map. I keep forgetting you can see this. So here. Ottawa would be approximately here, okay, in this area here on the map. So we are in an area called the temperate deciduous forest. I was telling the students today in class, the word deciduous is an unusual word. Okay, deciduous means trees with leaves on them, okay? And then coniferous means evergreen trees that don't have leaves. Okay, like pine trees and so on are evergreen trees. Pine trees, cedar trees, spruce trees, okay, like Christmas trees and stuff like that. So these would be evergreen trees. And they reproduce by conifers, and so, or by cones, and that's why we call them conifers or coniferous trees. Deciduous trees are the trees with leaves that you're familiar with. We live in a forest that's the northern tip of a forest called the temperate deciduous forest. And the temperate deciduous forest is characterized by the following. We have a fairly long growing season, okay, for plants to grow. We have higher temperatures than areas further north of us, which we consider the boreal forest just north of us, okay? There's lots of fertile soil in our area, and so it's good for agriculture, okay? And we have lots of precipitation. That's kind of important. Now, in terms of the biotic factors, we have deciduous trees and other flowering plants around here. We have tree and ground squirrels. There's too many of those, okay? We have lots of insects. We have small rodents and other mammals like mice, okay? Deer, black bears, not so much in the city, but out in the woods, okay? Hummingbirds, weasels. Now, let's just name a few. There are many, many thousands of other organisms that we're not mentioning here, but just a few highlights, okay? And you can see that zone down here. Now, this zone will continue on to the United States, which is not colored on this map, okay? So it continues down into the United States, the temperate deciduous forest, quite a ways down actually. If you were driving down south to the United States, if you were as far as Washington State, okay, you would see that the temperate deciduous forest is with you the entire time you're driving down there. So it's a pretty large geographical area. It extends all the way into the middle of our country until, or of the United States anyway, until you get to the grasslands, which are somewhere in the American Midwest and extending up into Canada, which is right here. Okay, so anyway, yeah, that's where we live, and so you're familiar with this temperate deciduous forest. All you got to do is take a walk in Gatineau Park, and you'll see what it tends to look like, okay, and there's natural environment. Here in the city, we only have little pieces of it, and we have broken up and fragmented that community up, you know, quite a bit here by building our city, okay, right in the middle of this forest. Most of Canada is what we call the northern boreal forest, or sometimes just the boreal forest. In fact, that forest extends around the entire globe. Okay, like so, Russia also has a boreal forest like this, and we call the whole thing, it's called the tiger. I'm not sure why. But anyway, this huge area in here that it goes all the way from Alaska all the way to Newfoundland, okay, is part of the what we call the boreal forest. And in fact, anywhere in that same latitude in Russia and Asia, whatever, they would that forest is there too, okay, and it provides a huge portion of the oxygen that you're breathing, okay, would come from this. So anyway, it's this area of Canada is largely untouched by human activity, which is a rare thing in today's world. So it's a lot of wild space, which is good. We really need to keep it that way. And yeah, that's it. That's the Northern Boreal Forest. What kind of characteristics does that have? Well, it's warm enough for trees to grow. Okay, so that's kind of important. They get precipitation, not as much as we get in further south, but they do get some precipitation. Some of it falls as snow, depending on the time of year. There is acidic soil. Okay, that not acidic because we have damaged it somehow, but it's just naturally acidic. There's no permafrost. Okay, that occurs further north in the Arctic tundra. Lots of coniferous trees. There are very few deciduous trees in that area. In fact, if you were to start in Ottawa and just drive a little bit north, maybe even just 1 hour, 2 hours north, you will find the prevalence of coniferous trees will increase dramatically as you enter this part of our environment. Okay, so pine trees. I'll show you some pictures maybe tomorrow. Okay, you know, there's various other animals that live there, including black bears, which extend through the whole region. Okay, and that's it. Now, I could mention these other ones, like the prairies are grasslands here, so it's not a forest. Okay, and for some reason the climate there does not support trees as much as it would, the environment does not support trees in these grassy sort of open plains for various reasons. Okay, and then we also have the mountain ranges over here, which are called the mountain forest ranges, and a large part of Canada, all throughout here, is called the tundra, and we call this line here, it is actually the tree line. You can actually drive north through this area, and as you pass the tree line, you'll find that the trees just disappear all of a sudden. Okay, so it's almost like there's a line drawn, like right on across the globe, where you cannot get trees further north than that line. Okay, and that has to do with abiotic factors like the availability of light and the temperature and so on. Okay. All right, so that's Canada for you. If I were to show you now, we're going to change the subject. We're going to talk about something that's very important in ecology. So I have skipped a few topics. I just wanted to mention the biomes to you. And this is, hey, pardon me for scrolling through it. This is it's going to take me a little bit to explain. So pay attention. You might want to take notes as we're going. Okay. This concept called ecological succession. This is really such a great thing about life on this earth, and I'll explain how that works. So there's a picture here that I will come back to later. So what is succession? Well, if you are royalty or something like that, succession is when okay, let's say Biden, let's use a more relevant example today. Okay, so today they're still deciding who's going to be the next president of the United States. If Joe Biden is successful, then he will succeed Donald Trump. Like, in other words, succession will take place and a new government will replace the old one. So that's what succession means in political terms. But in ecological terms, ecological succession is defined as the series of changes in an ecosystem when one community is replaced by another community. Okay? So, as these changes take place as a result of changes that are taking place in the environment in both the biotic and possibly the abiotic factors in that environment. Okay? Now, here's what's really special about succession. It can regenerate a damaged community. Okay? So, regenerating a damaged community. That is a big deal today. Okay? So, you know, I know the classic example that we use is Chernobyl, where Chernobyl, the town of 300,000 people, all 300,000 people just left. And what happens is now the forest has come back and it has reclaimed the city. Okay, that is succession. The forest has succeeded the people, right? Like it has replaced that community of people that live there. And yeah, you can also create a community in a previously uninhabited area. Now, what we mean in nature, uninhabited means no life, okay, at all. The best example I can think of is a volcanic eruption occurs, okay, and new rock is born. So new land is made from this volcanic eruption. This is where the Hawaiian Islands come from, right? Volcanic activity. So that new land, nothing lives on it at first. Nothing at all. Okay, so that's previously uninhabited. There's nothing there. And then what happens is life will take hold there. That's what life does on this planet. And eventually, in the process of a couple hundred years, a forest will form, okay, on that new rock. And you'll have kind of like a tropical rainforest there or whatever, depending on the environmental conditions. Okay, will depend what type of community you ultimately get. All right, this occurs basically everywhere. So all types of ecosystems, forests, ponds, coral reefs, so whether they're aquatic or whether they're terrestrial, it doesn't really make any difference. This process of succession could occur anywhere. All right, let's talk about primary succession. So primary succession, okay, is the process of creating and developing an ecosystem in an area that was previously uninhabited. Okay, so this is starting, I'm going to put a little note here. This is starting from, to use another term, scratch, right? Basically starting from zero. Now, where would you get this? Well, volcanoes, where you're getting new rock being formed. You're starting from zero. There's no life that existed previously on that area. Also here, there's a photograph of this here. You can see where a glacier recedes, it will leave bare rock. So the idea is it's bare rock is the starting point, okay, for primary succession. All right, so if you have no life at all, what happens? Well, life will find its way to your area. If you're on this planet, and like let's say a new island were to form because of volcanic activity, well, on this planet it will not stay uninhabited for long. And I don't mean humans entering it, traveling by boat. I mean that life will find its way to that planet one way or the other, okay? So you start off with no soil. That's really important. So what kind of life can exist without soil, plant life that is? Well, there are various things that can grow on the side of a rock, okay? The most obvious examples I can think of are organisms like lichen. Lichen is a type of organism that is photosynthetic, so it's able to manufacture its own food. And if you are living in sort of a place that had no life before it, you have to start with a producer, so it has to be photosynthetic. But lichen is not a typical type of plant. It doesn't have a root structure. It can just adhere to the side of a rock. You've probably seen lichen growing on the side of rocks before. It's sort of this greenish sort of color to it. You can also get algae. Okay, if the rocks have more moisture content or are wet, you can get algae forming on the side of a rock. Again, a photosynthetic organism, that in that case not even a plant. Okay, and so lichens, moss, okay, can form on the side of a rock. So that's what you start with. Okay, and it is a very slow process at first because there's no other life present. Okay, you start with the arrival of living things such as lichens and mosses, okay, that do not need soil. This is crucial. They do not require soil. Like a tree requires soil in order to take root. And there are many plants that require soil in order to survive. Okay, so these pictures here of these plants here, there's already soil present. So let's just move on to this. The species that first arrive, okay, in a uninhabited area are called pioneer species. So I just shaded that in here. They're pioneers. They're arriving for the first time. There's no one else there. So pioneer species are the first organisms to live in a previously uninhabited area. Here is a picture of lichen forming on the side of a rock. Okay, and here there's some mosses or whatever growing on the side of that rock. They do not require soil, and that is how they're able to survive and cling to a rock. Now, here's the deal though. Where did they come from? If you're wondering, like, say you're in a remote island in the middle of nowhere, where do these things come from? How did they get there? Well, their spores, they reproduce, some of them will reproduce by spore, and they release their spores into the atmosphere. And then wind will actually carry these spores, okay, in the atmosphere to the uninhabited rock. And then they will take hold of the uninhabited rock and they'll start growing on the side of the rock, okay? And that's what happens. And so there's nowhere on this planet you can go where these spores don't get blown around, okay? Even as in the middle of the ocean somewhere, spores will be carried from great distances, okay, this way. Now, yeah. So anyway, that's how the life arrives in the first place. So life basically moves in from elsewhere. Okay. A swimming pool at home is a great example of what's called secondary succession. But you treat the pool with chemicals, kills all the life in the pool, and the pool looks crystal clear. But then if you don't treat it, it'll turn green very quickly. That's from algae, blue-green algae, that will adhere to the side of the pool, and it's photosynthetic, and that is a pioneer organism, right? It can move into your pool, and it's the first thing that'll move in there. Eventually the pool would turn into a swamp, okay, and eventually it would actually fill with soil, and it would turn into forest just like everything else around here. Okay, because there's just not enough water there. It would fill with leaves and other debris until there was soil that was forming in the pool. And then, yeah, it would end up looking like, I'll show you a picture of an old pool tomorrow. You'll see what I mean. An old pool in the woods will quickly turn into forest, basically. Okay. So anyway, a pioneer species, we talked about that already. Now here's a key thing that happens, okay? Once the pioneer species take hold of the rocks that are in an area, and here we can see lichen on the side of a rock in this picture down here. What happens is as the lichen reproduces itself, lichen will reproduce, it'll die. More lichen, the new lichen will reproduce again and die again. And what's happening is these lichen are doing two things. Number one, they're breaking down the rock, okay, into smaller and smaller particles by adhering to the rock and breaking down the mineral in the rock. And as they die, they decompose and create soil. Okay, so they reproduce with sunlight. They don't need anything else to reproduce. They just need the right environment. And so they're reproducing with the available environment and nutrients that are present in the rock plus sunlight. And then as they reproduce and they die and reproduce and die and so on, they start forming small amounts of soil. Okay, and that's key because once the soil is there, seeds will blow in from some distant place, okay, and they will take root in the soil. Okay, so during the early stages of succession, there are not many inhabitants at first because the habitat is not nutrient rich to begin with. Okay, so what happens is as the soil forms, okay, flowers, ferns, and grasses can grow. Small plants is the key. Okay, so small, that can be small, can take root in that soil, and then what happens is that starts looking like a meadow, okay? A meadow that doesn't contain any trees yet. So like there are small flowering plants as we can see in this picture. So this is a meadow here where you got small plants, ferns, okay, and flowering plants that will take root, grass, etc., and can grow in small amounts of soil. Well, these organisms reproduce and die and create even more soil, okay? So, small plants, before we talk about that, small plants and animals will also move in once there's enough food for them, okay? So, for example, insects will be the first ones to arrive, and then it's possible that you can get small rodents and other animals as long as they have some way of getting there, okay? So if you're talking about, like, say, in Sudbury in Canada where they had acid rain that wiped out all the life and killed the soil there, okay? Yeah, what'll happen is when you fix that problem and succession starts to happen, these animals will come in from neighboring areas, okay? Flying animals, though, can even make it to remote islands, and that happens too. Okay, so over time, as animals and plants die and decompose, they add to the soil, okay, allowing larger plants to take root, okay, and populate the area. Now, the ultimate plant that could take root is a tree. These are the largest living things on the earth, okay, are trees. So like trees, if there's enough soil, trees can take root, right? And then as the trees reproduce and die, they form even more soil and you get more trees, but then you reach what we call a climax, okay? And the climax is basically a forest, okay, where you've got trees that are, you know, are the dominant species or whatever, and that's it. So eventually a mature community is formed, okay, and this community is called a climax community. Now in our area, that happens to be a forest. Okay, in the prairies, though, it happens to be grassland. Like, the prairies can't make it past the grassy stage because of the environmental conditions for whatever reason. I'm not 100% sure why, but that doesn't support very many trees. Okay, so you don't always get up to the forest level. Only if the environment is right. Like, desert areas barely get past the first few stages. Okay, so you don't get very much soil because the conditions are harsh in the desert and there's not enough water to sustain even the basic forms of life like algae and lichen that might grow on the side of a rock. Okay, so you have to have the right amount of water as well. Anyway, where we live, the climax community is definitely a forest. Okay, so here's the deal. This is primary succession. You start with rock, bare rock, no soil. The lichen and the moss and the algae and stuff will break down some of that rock, and as they die, they form soil. So here's the formation of soil being formed. Once you get enough soil, you start getting mature trees here that can take root in the soil, and this process takes hundreds of years. Okay? That's when you start from nothing. All right, what about secondary succession? Secondary succession is the process of repairing a damaged ecosystem. This is good news for us, guys, because we've damaged a lot of our ecosystems. But here's the thing. They can bounce back. Okay? Nature can recover. And they don't need us to do that. We don't actually have to do anything. We just have to stop damaging it, and it will recover all by itself. Okay? And this is the magic, okay, of our world and the life on this planet, is it can recover. Okay, from damage. Now, there are natural disasters that can cause damage, not just human activity, but there's natural disasters. For example, forest fire would be a natural disaster. That will burn down a swath of forest, but that forest will recover very quickly. You'll explain why that happens in a moment. Human activity can be a natural disaster, like in Sudbury, with the acid rain problem that they had there. Yeah, and there could be a death or dying off of various organisms because of disease or whatever. Say, for example, a certain type of insect destroys a bunch of pine trees because, it's particular to that tree. Well, that can be a type of disaster as well when a certain species of tree gets destroyed by some type of animal, okay, or insect. So, like by the way, around here, the emerald ash borer is killing all the ash trees, and you'll see them all over the place. Like, we can walk over to the woods, you can point out the ash trees. They're all being killed off by an insect called the emerald ash borer. Okay. Anyway, secondary succession happens much faster than primary succession. So it doesn't take hundreds of years this time. The reason why is because there's already soil. You haven't gotten rid of the soil. You're not starting on bare rock with secondary succession, right? So, secondary succession is happening all the time. That's worth pointing out. Like in the woods around us right now, it's happening when there's a forest fire that takes place. Okay, let's say in Gatineau or wherever the woods are. If it happens there, secondary succession will take place. Here we've cut down the trees and made say a soccer field. Secondary succession will take place there too, if we let it. Okay, if we keep picking out the trees and shrubs or whatever trying to grow in the field, then we'll keep it a field for as long as we let it. But if we left it alone, secondary succession would turn the field back into a forest, which is the way it started, before we ever got here. All right, so here's secondary succession in a nutshell. Let's say you get a fire, okay? Notice that there's soil. The soil here, I'll use a different color. The soil, oh, that's terrible. No, I'll use blue. The soil is always present, okay, the entire time. You don't start with bare rock this time. And in fact, what a fire does is actually enriches the soil with nutrients. Okay, some trees cannot reproduce themselves unless there's a fire. Like a fire is actually a critical part of their reproduction process. And so that's the thing about forest fires, is that they do serve a benefit to an ecosystem in certain circumstances. Okay, so you get a pioneer species that will come in after the fire, and very quickly, okay, you will get flowering plants. You can skip, you don't have to form the soil, right? So you can already skip ahead. So the soil is already there. So right away, plants that have root systems can take root immediately in this fresh new soil, or freshly sort of, if it was a fire, like it's rich in nutrients, that soil too. And so succession here, you can see these trees with large root systems taking root within just a few years. Okay, it says 5 to 150 years, but like we've seen areas like Sudbury that have recovered. There's already trees there that showed up. We're only 60 years out from when it used to look like the moon in Sudbury, with no life at all because of acid rain. Now we fixed the acid rain problem, and now the forest is back. That's only been 60 years since that. Okay. All right. So anyway, if an ecosystem is frequently disturbed, it will not be able to support large trees, okay, and animals. So it consists of the animals typically of the early stages of succession. This is what happens when we keep the trees from returning to a field or something like that. You'll only get the smaller animals that can live off that kind of environment, okay, and that's basically it. All right, so that is succession. So I hope that's okay. Now we're going to talk about this habitat. This is you know, part of me doesn't like talking to you about this because it's kind of a depressing story, but there's good news too. So let me get through what fragmentation is. This one won't take long to explain. Yeah, unfortunately, we live in a world that in the last 100 years or so, okay, has lost about 60% of its wild spaces. And that is a frightening prospect, not just for animals out there, but for us as well, because we are learning more than ever. We know now how interconnected everything is. So for example, if we lose habitat like our rainforest, that affects like the oxygen and climate on the entire planet, really. Okay, and that's if Brazil cuts down its rainforest, right? So this one area actually has a profound effect on the whole globe, the whole biosphere. And right now we are unfortunately creating a world that will be particularly inhospitable for creatures like ourselves if we're not careful. And so we really need to do something to fix like the problems that we've created in this environment. And it'll largely fall on your generation and the generations that follow to do these things. We got to start now though, okay, and make some changes here. All right, so if you've ever been to Montreal, the expo in Montreal, there's this weird habitat. This is supposed to be this building in the background here, it's supposed to be a totally sustainable habitat where people can live in these cool little apartments. It's a real place. It's a kind of amazing looking building, okay, with all these like, like these little apartment units. Like here, I'll circle one, there's a little apartment there, another one here. These little units are interconnected with a series of corridors, and yeah, people live in there, and apparently it's a very sustainable, okay, building. Okay, I don't know much about it, but I've driven past it, and it looks really cool. All right, so here's the deal. What is fragmentation? Okay, so fragmentation, what is that? And here's the thing. It's when we divide up, it's dividing up a region, okay, into smaller parcels, okay, or fragments. Now, a great example is like when you take like around this area, we have forested areas. That's the natural region that we live in, is the deciduous forest, right? So if you take that and construct a farm, well, what you're doing is just splitting up that habitat, right? And so here you can see in this picture, you can see some farmland that has been dividing up the forested areas. And we leave little narrow pieces of forest and stuff, but that's called fragmentation. Okay, now if you go to southern Ontario, you will see that very little forest remains, actually. So this area here is the only area that's untouched. Okay, and the rest of it is basically like, you know, that circled area there and this river valley here. Okay, those two areas, those are basically untouched. Everything else has been highly fragmented. Okay, so here's another picture of it here. Here you can see right now, like if I just highlight the forested areas, you can see how very little of the original forest actually remains. Okay, now if you were to go further north, it gets a little better, but you'd have to go, you know, maybe 2-3 hours driving north to get back into wild, truly wild spaces. Okay. All right, so here's the deal. In picture A, so here in picture A, you see a picture of what Ottawa might look like, okay, if we weren't here, if we never built the city. It's exactly what it would look like, this forest. Okay, and in fact, when the only people that lived here were indigenous peoples, that's still what it looked like, because they lived in a hunter-gatherer kind of society, and they didn't have large areas for agriculture, okay, set aside for agriculture, and they didn't have, you know, big cities or anything like that. And so they were living in a very sustainable way, actually, okay, in harmony with the environment. But then the Europeans came, and what they did was they saw this fertile land and built farms there, okay? So here, this same region here in this picture here has been highly fragmented by people cutting down the trees and then building farms, okay? So what's happening here is you can see an area of forest there. It's just a little rectangular edge. And then here is there's the areas here, you can see some farmland there. Here's another picture of it. So here is green space that they saved. So let me use the rainbow color. This space here, this space here. These are highly fragmented areas of forest, not very effective if you want to support a diverse community of animals, okay, that might otherwise live in that forest. Here, this is practically useless. You know, just this little tiny island of trees in a vast area of farmland. Okay, what's the point of even keeping the trees after a certain point? If you're trying to leave habitat for wild spaces, for habitat, you know, for animals, you're going to need to do a lot better than that. Okay. Yeah, here's like this sort of idea of Central Park. You know, like your park in the middle of a city. Well, that park, unfortunately, because it's so fragmented, like you won't see the typical type of animals that you might see out in the wild spaces, in the much larger areas of space. So, for example, if you go out in Gatineau Park, there are moose, there are bears, and so on. You don't see them because they're timid, but they're there. But this area here in the middle of a city will not support animals like that, because they're not going to wander through the city to get there. Okay, and it's not a large enough geographical area to support them in the first place. And so that's what fragmentation is. Okay, this is sort of like what Orleans probably looks like. Okay, so on the outskirts you'll see farmland here and here. Okay, in the outer regions, called Ottawa's green belt, or whatever. But then urban sprawl is creating fragmentations by building these little communities out there in the wilderness. Okay, or at least what once was wilderness. Okay, so here's the deal. Some depressing statistics for you. At least 83% of Earth's land surface has been transformed by human activities. That was as of 2002. I guarantee it's higher now, 18 years later. Okay? About 60% of Earth's ecosystems are considered degraded or unsustainably used. That's number is probably more like 80% now in 2020 versus 2005. Okay, 90% of the U.S. streams and rivers have been fragmented. Okay, 98%. So just 2% have not been by building dams. So that is one of the cons of building a dam, is that you fragment, like you block actually a normal passageway for aquatic organisms that might use that river as a transportation route. Okay. So anyway, that's the problem. So we've got a major problem with our wild spaces, and it's 100% us is causing the problem. Okay. So habitat degradation affects many but not all species. Okay. Habitat destruction and loss impacts nearly all species on this planet. Okay. And the time scale for recovery is very long. Now we talked about succession, so we know that it can recover, but we just have to stop damaging it in the first place. It's very important. Okay, so agricultural activities are the primary way that we damage an ecosystem or fragment an ecosystem. Extraction activities like mining can do some damage too. Okay, certain types of development, so building houses and everything. I mean, we need places to live, but we need to do it in a more sustainable way. Okay, so these are often considered to be the most important direct threats to something called biodiversity, which means like a forest is the most biodiverse habitat on the planet, especially a rainforest. If we start cutting it all down, then what's happening is species are going extinct and we don't even know it. By species we might not even have discovered yet, and by destroying their habitat, we're destroying them. Okay, so and we've learned that biodiversity is a really key thing to maintaining Earth's ecosystems. Okay, so we eliminate species, reduce population sizes, and reduce the performance of individuals. All right, so here's some interesting things. The island of Borneo used to be, in 1950, 100% pretty much rainforest, and supports a variety of organisms, including like orangutans, I think, are the one of the species of apes there, or primates. The island of Borneo, you can see where it's located here, just north of Australia. Okay. Yes, and what's happened is human development. What they're doing in Borneo is they're cutting down the rainforest and planting just palm trees. That's called a monoculture when that happens, and that has had a dramatic effect on the biodiversity of Borneo. Okay, so now this was projected in 2020. This is an old slideshow, so it's projected in 2020. Yeah, that projection has probably been even beaten. It's probably even less rainforest than that. There's just a tiny fraction of it left. Okay. Rare species are particularly vulnerable to this. Habitat loss even extends into remote areas like, look at this, this is the North Pole, where the loss of sea ice has had a dramatic effect, okay, on the habitat in the area. So here you get way less sea ice today, and that was in 2003. It's even worse today. And that has affected the habitat of, for example, polar bears. Okay, we're getting a 9% decline per decade, okay, of sea ice. Not good. These are areas where they have biodiversity hotspots, okay, usually defined by species richness. Okay, so these are where we're having problems with biodiversity because of habitat destruction, and that, is quite widespread, this problem. Anyway, you get the idea, okay. We need to better design, we need to set aside some spaces, okay, this is one way to fix these problems. Set aside some spaces that are wild spaces for wildlife to live in, where they can maintain their biodiversity. Okay, so let's say, how do we do that? Okay, well, I have a little chart here. On the left-hand side is the better practice. So you need a very large, you need a large reserve size. So if you're going to set aside some space for wildlife, make it big. Okay, small isolated places are no place for biodiversity. We need a large area. we would prefer one large area as opposed to a bunch of small areas. Okay, like this is not what we want. We want one larger area. If we're going to have areas that are smaller or many areas, they need to be close in proximity, okay, and not far apart. We should connect them so like they can be connected together with untouched passageways for the animals to move through, okay, undisturbed. So they should be interconnected. Okay, we don't want them long and narrow. Like we have a line of trees that goes down the Ottawa River from here all the way to the apartment buildings. But it's a really thin stretch of wild space. Okay, and it's not enough. It's not wide enough for it to really be effective like that. And so it's better to have a large area like this instead of a thin and narrow space like that one. We don't want that. A buffer zone where you have very little human activity out here, the outside. Okay. So like let's say for example you have Algonquin Park. Well, you can have places where people can camp, but you should have an area that's free of people altogether. Okay. And then this is better than not having a buffer zone at all. Okay. And that's the idea. All right. Deforestation in the Brazilian Amazon. Okay, 70%, cutting down the rainforest, guys. This is important for our whole planet. Okay, 65 to 70% of that is for cattle ranching, so for meat production. Okay, a small percentage, like 20 to 25% for small-scale agriculture. Large-scale agriculture, so those big companies, just 5 to 10%. Logging is just 2 to 3%. But really, the cattle ranching, guys. Okay, we got to do something about it. And it's not only Brazil's problem. Let's make that very clear. My solution would be to give them financial incentives to recover their rainforest. Like basically, we pay them to take care of it. And the reason why we would do this is they're just looking to make a livelihood, right? These cattle ranchers. We pay them. We say, listen, we'll buy you out. Okay, and we'll pay you money as an ongoing job to plant native trees. Okay, and and this has been done. This has been done in places like Costa Rica, where they had lost 2/3 of their rainforest for similar reasons. Okay, to the Brazilians here, and they recovered it in the last 30 years. They recovered 50% of that, and they did it by giving financial incentives for the locals to plant trees. Okay. And not just any trees, native species that are native to the rainforest. And they've recovered 50% of their rainforest. If we did that all over the world, okay, the trees that you would plant would actually offset all of the carbon we've ever emitted, okay, in the atmosphere. It's really a no-brainer. Okay, so anyway, I just wanted to show you that little picture. It's definitely not a problem for one country to solve. It's a problem for our entire planet, and we need to solve it as a species, as one human race of people, okay, working together to fix the damage that we've done and are doing to our environment. Okay, so anyway, I told you at the beginning that this kind of a depressing story. There's two ways to look at it. You can look at this with despair. You can say, oh, we've damaged our environment, and now we're in big trouble, and the future looks bleak. Or you can look at it like this. Look at Costa Rica, and they've recovered 50% of their rainforest by just doing the right thing. Okay. Look at Belgium, where they produce this massive amount of fruits and vegetables on a very, very small area of land. So they produce way more than they need, and they do that, okay, by using like hydroponics and greenhouse technology. Like you can grow all the food you need for a city, in the city, on rooftops, stuff like that. Why do we need to wreck all of our wild spaces when there's other ways of utilizing the available space to generate our food? Okay. Yeah, and like I said, Costa Rica is a great success story. There's another island nation that has reserved 30% of the sort of aquatic ecosystem that surrounds the island as a natural reserve, and it's amazing how that community around there has recovered. Okay, now they have so many fish, and like the fish stocks have completely rebounded. They've gone from the brink of extinction to almost completely recovered, and they did it by just reserving 30% of their space. And they allow fishing now because there's plenty of fish to go around now that they've used that 30% as a safe space for the fish to thrive and reproduce. Now the fish stocks are higher than they ever were before. See, and so it benefits us too. Okay, so that we know what to do. We have the technology, we have the minds to fix this problem. We just have to have the will to do it. That's where you come in your future, and that's why we're kind of hoping, that the election goes well in the States, if you know what I mean, because we need people making good decisions. All right, so that's it for today. I will see you tomorrow. Have a good rest of your day. If you're wondering about homework, yes, so in the homework, we are now at, let's see, for today we did equilibrium and succession, okay? So you got this. And we also did habitat loss and fragmentation. Okay, so we did these two things, so you got that also. So please go ahead and do it. We're going to cross this whole lesson out, so please don't do those. Okay, and so look, all we have left is pesticides. We're going to do pesticides, these two lessons here. That's all we have left. But for now, lesson 6 and 7, and we will talk more about it tomorrow. We'll finish off the course tomorrow. All right, guys, have a good day. We'll talk to you soon.